Good morning everyone. Last time we have seen some of the sums related to velocity and speed. Now today our next topic is rate of change of velocity. Rate of change of velocity, which is known as acceleration. A new physical quantity. Acceleration. It means changing velocity. When you take a rate of change of velocity, then our next or a new physical quantity is introduced, which is acceleration. Generally in our daily life, we never ride on a bike or moving in a vehicle uniformly, right? Generally, our velocity or speed can't be same at whole road. Due to some traffic, we have to decrease our velocity. And if the road is empty, then we are increasing our velocity. So like that, we have to change our velocity. And when we are thinking about that change in velocity and you are introducing a rate, how much change occurs in particular time, then you get a new physical quantity which is known as acceleration, right? So the acceleration is the value of rate of change of velocity, which is very important for our this chapter motion, right? And generally in daily life also, we are generally moving with a non-uniform motion in which our speed is generally changes. And just because of that, we can say that we are moving with the accelerated motion in which our speed or the direction of a motion is always changed. And just because of that, the new physical quantity is acceleration is introduced at here, right? What is the meaning of acceleration? Generally, you can say the definition of acceleration as a rate of change of velocity, or you can say that the acceleration means change in velocity per unit time is known as acceleration. Is known as acceleration. So you can say that the acceleration is equal to change in velocity divided by time. The acceleration is denoted by small a. It is denoted by small a. If we think that if one object moving with velocity u and after time t its velocity become v. Then what is the acceleration? The acceleration is equal to v minus u by t. The change in velocity, in which we have to always take a v as a final velocity and the u as initial velocity. Whenever you want to find the change during the time, you have to subtract the initial from the final. The first one should become a final, then the initial. So you have to subtract initial from the final, then you get the change in velocity. And when you take the rate of that change, then you get acceleration. So A is equal to V minus U by T. Now what is the SI unit? The SI unit of acceleration is, what is SI unit? Generally the SI unit of velocity, right? Velocity's SI unit is meter per second. So you can say that a change of velocity is also has a meter per second. If you want to subtract a 5 kg from the 10 kg, then what is your answer? It's a 5 kg. 10 kg minus 5 kg gives you a 5 kg. The unit is always same for the change, right? So at here also the change in velocity. If the unit of velocity is meter per second, then the change of velocity is also in meter per second. So according to it, the SI unit of acceleration, first of all it is meter per second. And as a denominator there is a T. The SI unit of T is second. It's a meter per second. Meter per second for V minus V. And denominator is T. So it's a second. So it gives you meter per second square. SI unit of acceleration is meter per second square. Understand? SI unit of acceleration is meter per second square. Not only that, acceleration is vector quantity. It's a vector quantity. So here it is the basic thing about acceleration. First of all, the rate of change of velocity, which is known as acceleration, or change in velocity per unit time, is known as acceleration. According to it, the acceleration is equal to change in velocity by time. The acceleration is denoted by A. If we take the initial velocity as a U and the final one is V, and for changing this velocity, the time is T, then the A is equal to V minus U by T, where the V is a final velocity and the U is a initial velocity. T is time, right? SI unit of the acceleration is meter per second square. Meter per second for the velocity and the another second is a denominator for the time. And the acceleration is a vector quantity. Watch it. Now, as I said, the acceleration is a change in velocity. Change can be at two different times. If you are thinking that the change is uniform, it can be increased or it can be decreased. If you think that there is one object, right, and this object is a stationary, so the velocity is 0, right? If I am free falling, then it just goes in a downward direction. If it comes at here, and in 1 second, the velocity becomes 9.8. In another 1 second, it becomes 19.6. In another second, it becomes 29.4. Another 1 second, it becomes 39.2. What is change? Just see it. At here, 0 to 9.8. So 9.8 is increased. The velocity changed by 9.8. At here, 19.6 minus 9.8, it also gives you a 9.8. So 9.8 is increased in 8. In every second, the change in velocity is same. It is increasing at the same rate. If we think a reverse process, if it goes in an upward direction, then what happen? Then this velocity is decreased by equal rate. This velocity is decreased by equal rate. 39.2, 29.4, minus 9.8, right? So at here, the change in velocity is same in the same interval of time. This type of motion is known as uniform acceleration motion. This is known as uniform acceleration motion. It means if moving object is if one object is moving on straight path, its velocity increase or decrease by same amount on in same interval of time. Then it is known as uniform acceleration motion. When we can say that it's a uniform? When its velocity increases or decreases at the same amount. Like in our previous example, the 9.8 is increases. The rate is same. The velocity is increases by the same amount in the same interval of time. Not only that, after that, it is decreases when it is going in upward direction, which is also in the same amount. Then this type of motion is known as uniform acceleration motion. Right? If we take a non-uniform, here it is uniform. Here it is non-uniform. What's happening in non-uniform? If an object is moving on a straight path, its velocity increases or decreases by different amount in a same interval of time. If one object is moving on straight path, its velocity changes by different amounts in same interval of time. Then it is known as non-uniform acceleration motion. So here is the two definitions. First the uniform acceleration motion and then the non-uniform acceleration motion. Just watch for 2 seconds. So now here is the topic acceleration. Next we'll see in another lecture.